I'm going to be comparing a couple different mixing techniques from my electroplating tank. If you do a search, you'll find there's been a lot of research done on agitation. I like this one paper especially well. It provides an overview of the topic and delves into some of the different agitation techniques, talking about some of the pros and cons that go with them. The paper introduces a metric called an effectivity factor. It provides a method of comparing the different agitation methods. Of those listed, I'm going to be concentrating on mechanical stirring and air sparging, as they are the most relevant to the scale at which I'll be working. I did spend a couple days playing with the eductor jets. It was good fun, but quickly turned into a rabbit hole that I thought in the end would be overkill for what I planned to do. My approach to doing this investigation was to introduce something to the tank and see how long it took for the solution to become homogeneous. But what to introduce and how? So to do the agitation study, I first needed to do a study. I needed something water-soluble with a pigment that would show up well. Food coloring was the obvious choice, but I thought that would work too fast to differentiate between the agitation methods. I tried several kinds of paints, watercolor, tempera, and some paints claiming to be water-washable. Once dry, none of these readily dissolved in the water. I moved on and tried some different dyes for icing cakes. I finally settled on a concentrated gel-like icing colorant. But what would be the best way to introduce the color? I tried painting on a stick, on some cloth, and a plastic mesh. I chose the plastic mesh wrapped in the cloth. The last decision was what color to use. I had 3 choices, and they all dissolved equally well, so in the end I chose blue. It showed up well and was reminiscent of copper sulfate. Plenty of people get good results without any sort of stirring, so why bother? Well, I want to get the best results I possibly can, and this is a good step to optimizing my processes. At some point, I'll almost certainly make a mistake, maybe get lazy with my chemistry or some other goof. My belief is that the better my underlying process, the more margin I'll have, and the more forgiving of my errors it'll be. Stirring brings a few things to the table. First is to make the distribution of the metal ions more homogeneous. You've got metal coming out of solution at the cathode and metal going into the solution at the anode. This creates a concentration gradient between the cathode and the anode. This increases the impedance of the solution, so more voltage will be required to maintain the same rate of deposition. Second, I'll be heating the solution, and without stirring, there will likely be hot and cold spots. That in turn could affect the quality of the deposit. For these trials, I'll be using hot water from the tap, and I've got a timer going to see how much of a difference there might be between the different approaches. This first trial is to establish a baseline by doing nothing and letting the dye passively diffuse through the solution. Watching the process is mesmerizing. Air sparging is nothing more than bubbling air through the solution. There is no question that this works pretty well. However, it has several potential issues. If an air compressor is used to supply the air, care has to be taken to remove any oil from the air so it doesn't contaminate the solution. Air is non-conductive and it will reduce the overall conductivity of the solution. Also, the extra oxygen will oxidize and degrade the solution. You can probably tell I really don't want this to be the best answer. This is mostly because of how much of a mess that bubbling creates. But wow, it does a really great job. Stirring can be implemented with several different variations. A shaft can drive a propeller, or the propeller can be magnetically coupled. The propeller can be different shapes, and there can be multiple propellers. In this trial, I used a magnetically coupled stir bar. I did spend a lot of time trying to implement a system to drive 2 stir bars. I did get it to work after a couple of months of fooling, but decided it was more trouble than it was worth and abandoned the approach. The single stir bar was driven at about 500 rotations per minute. Any faster and the bar would lose lock and go flying off to the corners of the tank. A nice vortex did form and was visible on the surface. And while close, it didn't mix as fast as the bubbler. Early on, I decided to not fool with jetting, but I couldn't resist and I looked at a spray bar sort of approach. The first thing I did was knock together a simple spray bar and power it off the kitchen faucet. Hopefully I cleaned up the mess well enough that the wife won't notice. From there, I put together a setup to provide a proof of concept. It worked, but not as well as I expected. I attempted a different demonstration and was so impressed with the results, I was sold on the approach. The spray bars each have 20 evenly spaced holes. The two bars are offset so the streams pass by each other and impact on the opposite wall. I've tried to set the angle of the stream so it would impact about 2/3 of the way up the wall. I think the one arm is a bit off, but I think it'll be fine. So which approach is best? The correct answer to many engineering problems is that it depends. In all of the demonstrations, I gave minimal effort towards optimization. The bubbler was the quickest to homogenize the solution, but if I had tinkered with the size of the bubbles, the rate of the bubble formation, and the distribution of the bubbles through the tank, it could have possibly worked even better. In the case of stirring, more than one stir bar would have helped create a more turbulent solution. Possibly even changing the shape and size of the stir bar would have helped. And with the jets, I think there's a trade to be made between the jet velocity and the volume being turned over. In short, I think any stirring is probably better than none. From there, it's just a matter of optimizing with the resources available to you. I hope that this video was at least entertaining. My next phase of this project is to put together a system to control the temperature of the plating solution. Until then, take care.